What's up, guys? Hey, Devs here, and I'm forgetting my glasses today, but it's fine. I really do not feel like getting up and getting them, but I hope you're all having a wonderful day. And, we're back with some more LeetCode, doing it every day until I get a job. As you can see, I came up with a solution to this problem. It's pretty simple, I would say. It's not too bad if you break it down step by step. And I'll draw it out on the screen so we can go through this together. But this should be day 11 of doing LeetCode every day until I get a job. And I got home from work about an hour ago. I had to run something to my dad's house, so then I got home like 30 minutes ago, and then out of the shower like 20 minutes ago. And I'm going to the movies tonight. Me and my girlfriend, we're going to see the new Demon Slayer movie. So I want to do, well, this is technically a medium problem, but the solution isn't too complicated, and it didn't take me too long to come up with. So we're going to run through this real quick. Just for sure want to get a video out there. And then tomorrow morning, I think, I've got work tomorrow at 4, but I should have more time in the morning just to do some LeetCode. And I got some other assignments I got to do tomorrow. But tomorrow, I think we're going to do a hard problem, or try to. And I think we might go back to the hard problem I tried to do the other day. The one I talked about yesterday. In yesterday's video, I can go ahead and show y'all. It is the reverse nodes and K groups. Now, now that we know a decent way, see, this is my long, super complex solution. We're just gonna go ahead and get this out of here. But this one isn't too bad. We just have to keep up with like 3 different pointers, and then we're able to link everything around one by one. And this problem we did yesterday, which was the reverse linked list, should help us do that solution. It's just we break this one problem down into sub problems, right? Like we could yeah, anyways, I mean, not to get too ahead of myself, but this problem, reverse linked list, is going to help us conceptually do the reverse nodes and K list. So I think I'm going to try to get that one done tomorrow. But let's go ahead and hop into today's problem. We're doing problem number 24, more linked list. I think we got 3 more days of linked list, and then I'm going to hop on probably, I think we're going to do binary trees list next, because that has to do with nodes, and we've been doing a lot with nodes, right? And we might do another array problem tomorrow or the next day. But this is problem 24, swap nodes in pairs. Given a linked list, swap every 2 adjacent nodes and return its head. You must solve the problem without modifying the values in the list nodes, i.e. only nodes themselves may be changed. So what that means is we can't create new nodes in a new list. We have to reroute the links they have, and that's the only thing we can do. As you can see in this first problem, it's 1, 2, 3, 4. So we have these 2 nodes that they want us to swap around. So if we break these 2 links, we want 2 to point to 1, we want 1 to point to 3, and then same thing here, we want to break this link and this link, and we want 3 to point to null, and then we want 4, or we want 1 to point to 4 now, right? And this looks like a bunch of mumbo jumbo, but eventually it'll get us 2, 1, 4, 3. And then down here at the next problem, let me go ahead and get the pointer. The next one, so if it's 1, 2, 3, and it's an odd number of nodes, we won't swap the 3 around with anything, we'll just leave it as is. And then we'll return the head of that list as well. So this one kind of goes along the same way we did the reverse list yesterday. We want to have, I think we create 3 list nodes variables in this. So we want a solution node, and this will have a new list node with a dummy value, and it's going to point to head. What this is going to do is, if we return solution .next, it will actually have the head of the value, like it will have the head of our new list, right? So then we have a list node previous, and we want that to equal solution, right? and then we want a list node current, and that's going to be equal to head. So kind of what we did right now, drawn out, we created a new node. Ooh, that's too big. We created a new node right here. Let's go ahead and, oh, what did I do? So we created a new node here with a 0 value. This is pointing to the head of the list, so it's pointing to 1. We're creating a p node, and the solution node is both going to be equal to this node value. And then we created a current, which is equal to the head, right? And our solution is we want to create a next node. As long as current.next is not equal to null, we want to hold a a next node right here. And then from here, we want to break off this link. So we want to set current.next equal to next.next, right? And then we're going to link this one around. And then we want to set next.next. We want to break this link, and we want to point it back to current. So next.next is going to be equal to current. And after that, we want to set the previous node, which in this case is 0. We want to set p.next equal to next, right? And all this mumbo jumbo will be down here. And without this mess that you see right here, the p is going to be pointing to 2 now. As you can see, we broke this link and we made a new link pointing to next. Next is still going to be pointing at the 2 node, and then current is going to be pointing at the 1 node, and as you see, it's linked up to 3. But we haven't done these 3 values yet, so you can imagine this is still 3 and 4 for the first iteration. So then after this, after the first pass, we want to set p equal to current. So p is going to be down here. And then if current.next is not null, we want to set current to current.next. And then we will, now that we have p and c initialized, we will create an n. Then we'll break this link, we'll break the second link, and then we'll go on till the end, right? So that's kind of the solution I came up with. And we'll go ahead and type this out and explain it down the way. So now that we have our solution node, our previous node, and our current node, we want to loop over this while current does not equal null, right? And the first thing we want to do is if current.next is equal to null, we can go ahead and break out of the loop, right? And then if it does not equal null, we'll come out of the loop, and we'll be, or not the loop, the if statement, and we'll be right here, and we want to set a list node next equal to current dot next, right? And then after that, we want to, now we have our dummy node right here, which is set to p. And then we have our current node, and then our next node, right? First thing we want to do is break the currents link and set it to c is equal to n dot next, right? Hard to write with a mouse. So then we want to set cur.next is equal to next.next, not c equal to n.next, c.next. And all the cur.next is equal to next.next line does is it breaks this link that it already had, and it sets a new .next pointing to 3, right? Next thing we want to do is we want to break the next.next's link, and we want to set next.next's link to the current node, okay? So the next line would be next.next is equal to current. And then the last thing we want to do is we want to break the previous node's link, and we want to set it to next. So we'll establish a new link. So previous is equal, previous dot next is equal to next. Okay. And then after that takes place, our C will be pointing to, or our N will be 2, and our C will be 1. And you can imagine, since we haven't swapped these pairs yet, because this is the final linked list we want to get to, we want to set P equal to C. And then if C's dot next is not null, we want to set we want to set C equal to C dot next. Okay. And then after that, we have successfully swapped 2 pairs, and we're on to the next 2 pairs, and we'll continue this these 4 swaps to swap the values around. All right. So next we want to set previous equal to current, and then we need to check if current.next is equal to null, and if it is, we can go ahead and break. And if not, we can set current.next equal to we want to set current equal to current.next. So what this does is, so after the first iteration of this, we already established that these 2 nodes will be swapped. We can go ahead and let's draw this out. So we have our 0 dummy node pointing to 2. Both of these links are broken. 1 is now pointing to 3. And then 2 is pointing to 1. And we just set previous equal to current, so P will be at 1. And current is equal to current.next, so current is at 3. And now we want to swap 3 and 4. So we can go ahead and walk through the algorithm one more time to kind of make sense of it all. So current is not null, as we see here. We could say while true if we really wanted to, because this solution will break out no matter what. It will never set this equal to false, if that makes sense. It'll break out of the loop before it does that. But we can go ahead and go through that one. So current.next is 4, and it's not null. So we go ahead and go to the next line. We create a list node next is equal to current.next, which is 4. So we have our next node here. And then we want to break the current.next's link, and we want to set it to next.next. Well, next is not pointing to another node, but it's actually pointing to null. So C will be pointing to null now. And then we'll set next.next equal to current. So we'll break this link, and we'll set 4 equal to 3. Or point to 3, and then we want to set the previous dot next equal to next. So this breaks this link and now points P. We will do that the other way. It sets the P equal to 4, right? This kind of looks like it still looks like some mumbo jumbo. But if you look down here, P is right here at the 1 node. And it sets 1 pointing to 4, which is what we want in the final list, right? And then we set 3's pointer to null. The 3's right here. And if you see at the completed list, 3 is pointing to null right here. And then we want 4 to point to 3, which is what we're doing right here. And then now we want to check if current.next is equal to null. And since it's not, we can go ahead and break, and then current is equal to current.next. Well, actually, we don't really need this if statement, because the while loop does check that. And that should work if we remember all of our semicolons. Yep, once I said again, we need to remember all of our semicolons, guys. Simple syntax errors. Yep, so this works for all four of the test cases they give us. If we go ahead and submit this, and it beats 100% with 0 milliseconds. It has a time complexity of O of n, since we loop over the entire array one time. Or it would be like O of n divided by 2, but like you get rid of the 2 and it's just O of n. And it has a space complexity of O of 1, because the only thing we create is a new list node head, just to point to the new solution. And while current does not equal null, so that means we haven't made it to the end of the list yet. And then if current.next is equal to null, it would be similar to case 4, where current is at 3, but current.next is actually null, because it has an odd. This means that there's an odd amount in the list if this breaks, and if there isn't, we want to relink the last 2 nodes, right? And then list nodes.next is equal to current.next, so that establishes the node we want to swap with the first node, and then the current.next and next.next and previous.next, that is relinking everything. So we need to keep up with the previous node and the 2 nodes we want to swap. That way we can swap the 2 nodes and then point the previous node to the new next node. And then all this is doing is incrementing previous to the previous node, and then current to the current.next node, and then next will be set to current.next, right? Yeah. I don't think this is too hard of a problem for Medium. It just takes a little bit of brain power. As you know, we have been working on linked list all week, so we've had a lot of practice with linked list, so we've been slowly getting better at the linked list problems. And like this solution, I came up with it in like 5-10 minutes probably. But yeah, let me know what y'all think of the Epic Pen. I think the Epic Pen's pretty cool. Being able to write, have like an overlay on the screen, and be able to write out the algorithm or what I'm thinking about. And yeah, so if you have any questions, comments, concerns about or what I wrote right here, or anything, we can go ahead and check out the solutions tab too to see. I like this guy. Oh yeah. He kind of had the, his kind of looked like my slop. And then we can let's go and look at his solution and see what his. Yeah, so he for each iteration he goes ahead and checks current and current.next. So you could leave this out, and you won't have to do that. And we create a current, and next is equal to, I don't know what second is, second.next, current, previous, npn. So it looks like looks like we used one less list node than he did. He set his current.next right here. That was kind of hard to spot because he put them both in the same line. And then we created our next node inside of it. But all in all, the solution's the same. We have three lines of code to reroute our links, and then we have 2 lines of code to set previous and current.next to the next. Okay. yeah, pretty happy with the solution. If you have any questions, comments, or concerns, of course, leave them down below. I will be back tomorrow with another LeetCode video, and yeah, I think that's gonna be all for today. I want to make a short and sweet video because I didn't want to do too much today because we're about to go to the movies, and I just got off of work. I'm kind of tired. But tomorrow, I think we're going to try to tackle the reverse nodes and K groups given the head of a linked list, reverse nodes in K times. So K is equal to 2, so we swap 2 nodes around, and then K is equal to 3, we swap these 3 around. Yeah. Anyways, y'all have a very nice, blessed, and beautiful day. I'm going to finish getting ready. We're going to leave for the movies in probably about an hour. So, y'all stay blessed, stay healthy, and leave any questions, comments, or concerns down in the comments below. And if you have any recommendations or problems you would like to see, go ahead and leave them down below as well. And I will see y'all next time. Hey Devs out.